So this is a galvanic cell. This is the first kind of cell that we're going to be talking about. Galvanic cells are spontaneous cells, and they're just like batteries or anything else that you use to power something. And of course, we make them all fancy and all everything. And you can learn about more details about galvanic cells if you just Google the term or look in a book. There's always a lot of information on this topic in the internet. So for a galvanic cell, there's a few key features of that galvanic cell. Like I said, it is a spontaneous reaction and it is giving up electrons. Remember that anode and oxidation, they both start with vowels. So this is our oxidation. So what that needs to mean is that our electrons are being released. So we have something that's neutral, our lovely piece of metal, and the electrons are being released and they're flowing in this direction up a wire. Now, these solutions have to be separated because we want the flow to be up a wire so we can hook up something to it and we can make something go. If they were just like in the solutions, they might just be trading off electrons back and forth like that. And that's not what we want them to do. We want to use that electricity. So that's the first thing. So as that's happening and as those electrons are going in that direction, then our Y right here, it's starting to slough off and it's going into the solution as a Y positive because we know that ionic things tend to be soluble in water. So our anode is actually, as the reaction progresses, is going to get smaller and smaller. Now, notice also that our anode is negatively charged. So if we're thinking about like the poles, or if you've ever used like alligator clamps to run different reactions, so we've got our negative, which is typically represented with black. It doesn't have to be. That's just like kind of traditional. It's like the black side. So that one is our negative, and that's where all the electrons are. So that's why it's negative. And they're attracted to the positive pole. And again, this is just a wire with little alligator clamps or something like that connecting them. So the wire itself is not positive or negative. It's where the electrons want to go is the positive and the negative. So then in this case, we have another piece of metal over here. And I like to have this be positive and that be neutral because I think that that's easy to see. So we have like some Z plus in the solution over here. And so we have to set this up with the solution so that that's already there. Because the electrons, when they come over and they're kind of like flowing around this metal piece, they need to hit the water. And this needs to be close enough that they can grab or react with it. And it adds to the metal. So as the electrons are coming in, they're reacting and they're adding to the metal. And so this one is actually getting bigger. And like I said, this pole right here, this would be a positive pole because it is the side that it wants electrons. The electrons are interested in traveling in that direction. So they're attracted to go and do that. Don't forget that the look of this reaction on this side is that we have an electron reacting, making some kind of a metal right there. So notice that this electron is what's reacting with this to make that. And remember cathode, anode. So that one gets bigger. And this is really interesting because you can actually, purify things with some of this process. And overall, here's like an overall reaction. I'll go ahead and change my signs on this though. So that's your galvanic cell. One last thing though, I left something really important out when I was describing this all because I didn't happen to have it in the picture. This cell won't flow like this unless we have something that helps us charge balance our solutions. You'll notice that this solution is becoming more and more positive, but over here, this solution, it's actually becoming more and more negative because the ion that was balancing this when we made the solution, that's also in solution, it's losing the positive balance. The positives are going in that direction. So this one has actually got all this extra negativity in it. So it's going to mess up the flow of the circuit unless you have a salt bridge in there. So the salt bridge is usually something like wet that allows the flow of actually the ions on this side to flow to this side. So the negatives help balance out the positives in that solution. And if need be, the positives can flow in that direction and balance out the charge in that solution. So we're only wanting the ions to flow with that. We do not want, our electrons to do anything with that. That's why it's usually like a porous material or like paper, filter paper, that kind of a thing. So you got to have the salt bridge to keep this balanced to even get the reaction to go.